Calling all of you, welcome to one more session for the data representation. Now, today we will be dealing with the types of the conversions, that how many types of the conversions are over there and how are we going to do that. So, as I told you in the previous session, that we will be dealing with three number systems, that is a binary number system, a denary number system, and a hexa number system or a hexadecimal. So now with the three types of the number system, we do have six types of the conversions, that is from binary to decimal, decimal to binary, binary to hexa, hexa to binary, hexa to decimal, and decimal to hexa. Okay, decimal or denary is the same thing, so don't get confused regarding that thing. Now coming towards binary to decimal or to binary to denary. Now what do we do for binary to decimal? Now let's assume we do have a number 1100101. Now we need to convert this number into the decimal number format. How are we going to do that? So we are going to multiply 1 by 2, then again 1 by 2, addition between them, plus 0 by 2, plus 0 by 2, plus 1 by 2, plus 0 by 2, and plus 1 by 2 once again. That means each and every bit will be individually multiplied by 2, and the sum we need to find out of it. Now we need to give the powers towards the zeros. So starting from the right hand side, power always starts on the right hand side. Okay, so 2 power 0, 2 power 1, 2 power 2, 2 power 3, and so on till 2 power 6. Now what we actually did, we multiplied each of the number by, that means each of the bit, by the power of the 2. So 1 is multiplied by 2 power 6, that's 64. Again 1 is multiplied by 2 power 5, that is 32. Now for the zeros and the zeros, because if I am going to multiply anything with a 0, that completely says that it's a 0 once again. So I just wrote a 0 over here. Then 1 by 4, I'm sorry, 1 by 4, 0 by 1, 0, and then 2 power, yeah, sorry, 1 into, sorry, 2 power 0, 1 by, I got a bit confused. So 1 by 1. Then I'm going to add them all together. That's a 64 plus a 32 plus a 0 plus a 0, 4 plus 0 plus 1, and then finally I'm getting the answer 1 1. Okay, now it's a bit lengthy procedure. Now for the O levels or for the IGCSE students, what do we actually do? We do this alternative method. Now what we need to do, we just separate each of the bit from one another and we write the powers underneath it, or you may write at the top as well, that's not an issue. 64, 32, 16. Now I'm going to consider only those bits that are on right at the moment, because if it's a 0, that means the bit is off right at the moment and it's not considerable. So if I'm getting, or I'm considering the on bits, that means 64 will be added by 32, will be added by 4, and will be added by 1, and finally I'm getting the similar answer, the 1 1, that I was getting with the previous procedure. So this is how we need to convert a binary number into a denary number. Now coming towards denary to binary. Now how we need to convert a denary number into a binary number? Now converting a denary number into a binary number, we do the LCM method, that I find actually easy. Otherwise you can do a subtraction method as well. You can learn that thing from my lab classes or something like that. Otherwise that's an easy procedure, so I will be going with that procedure. So 101 is my number. Actually what I have done over here, I just took the similar number that I got as an answer in the previous part, that was from the binary to decimal. Now we are reverting that decimal towards the binary. So just to make sure that I'm getting the same answer as I got from the question, oh sorry, I'm getting the same answer as it was given to me as a question in the previous part. So what I'm going to do, I'm going to take the LCM. Now for the LCM, 2, okay, 1 cannot be in the table of the 2, so I'm going to merge it. So it's 10 right now. So 2 5s are 10. 1 is left now. So 1 cannot be in the table of the 2. So we will be placing a 0 over here and 1 will be at the remainder. Now 225 is a 50. So remainder will be 0. 2 12s are 24. So remainder will be 1. 2 6 are 12. That means remainder again a 0. 2 3s are 6. That means a 0. 2 1s are 2. That means we do have a remainder, that is a 1 over here. Now how we need to write the answer for this thing? We cannot further simplify that thing. So starting from the left hand side, coming towards the right, that means the last thing over here will be considered as an answer. So 1 1, then 0 0 1 0 1. So this is our answer, and if you can see, it is matching the question as it was given to us, 11 00 101. If you can see over here, so it's 11 00 101. So we are getting the same answer. That means we have done the previous part right. Now coming towards binary to hexa. So for binary to hexa, I have again taken the same number, that's a 11 00 101. Now as I told you that hexa is working on 4 bits, not less than that, not more than that. So over here, what we are gonna do, we are going to utilize the pairing method. Now how are we going to utilize the pairing method? So do remember that pairing always starts on the right hand side once again. So in the pairing method, the first pair is going to be 0101. So if you can see over here, it's written 0101 over here. The other pair one will be 011. Okay, now for 011, I need to complete the pair. Now what I'm going to do, I'm going to place up a 0 over here to complete up the pair. So it will be 0110, and now we will be doing the similar task, 8421 or 1248, however it feels comfortable to you. Now these are actually the answer of the two powers. Okay, so 2 power 0 1, 2 power 1 2, 2 power 2 4, 2 power 3 8. So in this pattern we are going to get this thing. Now for the next pair, now it is a new pair, so similarly we are going to do with that 2 power 0, 2 power 1, 2 power 2, 2 power 3. Now we will be checking out which bits are on, that means they are considerable, and which bits are off, they are not considerable. So over here in this pair, 4 and 2 are on, so it will be giving me a 6. Over here 4 and 1 are on, that means it will be giving me a 5. So after that I'm going to merge both of them together, that will be giving me a 6 5. It's not a 65, do remember that we are converting it into the hexa, so it's not a 65, it's a 6 and a 5. Okay, so this was how we are going to do with the binary to hexa. Now coming back towards hexa to binary. So for hexa to binary, what do we have? I took the same thing as a question that I got as an answer. So 6 and 5, we just need to reverse that matter. We are going to write down 6 separately, we are going to write down 5 separately. Now we are going to check it out that how 6 is represented on 4 bits. So it's 0110 and 5 will be 0101. So what you actually need to do, you just need to merge all the bits together. So 110 0101. Okay, now make sure for one thing. Now this answer is on 7 bits. If the examiner asks you to write the similar answer on the 8 bits, so what you need to do, you just need to increase up a 0 in the initial, 011000101. Okay, make sure for one thing, you cannot add up a 0 over here at the end. You not add up over here. Okay, you need to add the 0 at the starting, because what if you are going to add up the 0 in the end? So let's consider this thing. It's 1 2 4 8 16 32 64 and 128. So these are the 8 bits. Okay, now the actual number was 11000101. So that is giving you a the decimal representation of 101. Okay, now if I come, or if I just shift it, or I mistakenly wrote this number in this pattern, 11000101, and I place up a 0 at the end that I was actually talking about. So what has happened now? Now the actual number was 101 in the decimal format. Now if I just by mistakenly write 1 over here and I added up a 0 over here at the last, okay, just right over here. So what is going to happen? The number will be doubled. Do remember that if I'm going to shift one place to the left, that means the number is going to be doubled. Now if I'm going to check it out, how it is doubled. So what are the bits that are on right now? It's 128 that is on, 64 that is on, then 8 is on, and then 2 is on. So 8 plus 2 give me a 10, plus 64 gives me a 74. 74 plus 128 will give me a you may do it in the 128 plus 74. So 8 plus 4 12, 2 1 carry, 3 and 7 0, 1 will be carry, and again a 2, so I will be getting a 202. So as I just told you, that number will be doubled. Similarly, what if I shifted one place to the right? So do remember, shifting the actual number one place to the right will give me a half of that number. For an example, this was the actual number. Now I am shifting it one place to the right, so I will be writing 110010, and first of all actual bit is lost and the zeros will be added to complete the 8 bits. Now what are the bits that are on? So 32 is on, 16 is on at the moment, and 2 is on. So 2 plus 2 4 plus 6 10, 0 and 1 will be carried, 4 and 5. I think so I made a mistake. Number should be halved. It was, the actual number was 11100101. Okay, yeah, right. So what actually I am doing right at the moment, if I'm shifting it one place to the right, so this one is transferred to 32. 32's bit is transferred on 16. Then it was on 4, so it is transferred over 2 at the moment. So this is how the number has been halved of it. This is actually what we are doing over here. So make sure for this thing. Okay, so if you're shifting one place to the right, the number will be half, whereas when you're shifting one place to the left, so number will be doubled at the moment. Coming towards denary to hexa. Now for the denary to hexa, again I took the similar denary number, that is 101. Now once what we were doing, we were converting from denary to binary. So we were taking an LCM by 2. Now if I need to convert denary to hexa, so I will be taking an LCM by 16. So for your ease, in my notes, what I have done, I have written the 16 table, because usually the students are not aware of the 16 table. That's the reason that I have mentioned it over here. So now 16, 6 are 96. Okay, now 16, 6 are 96. Now what is the thing that is left over here? 4 is left over here. Sorry, 16 6 are 96, and sorry, my bad, I got confused. 16 6 are 96, so remainder will be 5 over here, so I just wrote a 5 over here. 6 and 5, we will be writing the answer in a similar pattern. So 6 5, we are getting the answer in the hexa form. Now coming towards hexa to denary. Now when we are converting from binary to denary, so we were actually multiplying each of the bit by the power of the 2's. Now when you're only converting from hexa to denary, so what we need to do, we need to multiply each and every digit by the power of 16s. So here we are. 6 will be multiplied by 16, we'll be getting a 1, plus 5 multiplied by 16, again we'll be getting a 0 over here. So 6 into 16 plus 5 into 1, so 6 into 16 will be 96, 5 into 1 will be 5. Adding them both together will giving you a 101. So that was the type of the convergence that we actually need to do for our GCSE or IGCSE. And yeah, do remember that we are doing the similar type of the convergence in your AS level as well. Thank you so much. We'll be continuing further in the next session, that will be regarding that how we need to deal or how we're going to recognize the negative values. Thank you so much guys. Allah Hafiz.